So yeah, today we'd like to talk a little bit about our assistive technology project. This project essentially is going to center around visual impairment. So we're basically going to outline our progress so far and any plans that we have for the future.
Yeah, in this presentation, you will get our general overview about what we want to achieve through this project, and we'll showcase you to the general overflow, our design and implementation processes, and the final lessons we have learned over the course of the weeks we've been working on this.
So first, I'll give you a general introduction to our project. So for a little bit of background, our project focuses on providing assistive technology to basically help visually impaired visitors of the Lewis and Clark Trail located in Montana. And so basically with this project, we decided to create more tangible depictions of various plants along a nature trail by using 3D printing technology. In terms of implementation, we plan to do this via tactile image representations of the actual plants, as well as printing braille that points to a QR code that then the users can scan and get an audio description of the plants as well. And by doing this, we hope to create an overall more enjoyable experience for those who access information in a different way. So our mission statement is to design and build tactile representations of plants along the Lewis and Clark Trail so as to provide an equally immersive experience for visually impaired visitors.
Yeah, so for the tactile prints and braille scripts, we chose to build them, develop them so using 3D printing, because not only is it affordable, it's also you can easily manipulate the dots and change the designs to achieve finer and finer levels. So for braille scripts, this is our general workflow. So first we prepare the text. There are different guidelines in different countries for the brailles, and for our purposes, we're using US1, which is uncontracted braille. And we use this program called Perky.doc to match the braille that we get in our 3D software, to match it with that to check the accuracy of the text. The 3D software that we're using is called Fusion, and it has a braille creator plugin which allows us to easily just enter in a text from English, and it automatically translates into braille scripts. And then we actually start getting into modeling it by editing the braille sizing, dot diameter, the horizontal spacing between this dots, and we follow the regulations that's mentioned in the bottom left corner. And then finally, when we try to extrude the sketch, we try to achieve a maximum fillet option to smoothen the dots and give a more immersive reading experience. Then the third step is the actual printing, and for that we set finer and finer. We set different braille sizing in the printer and to get cleaner results, and we change the retraction speed. We change over extrusion and under extrusion, and then after printing it, we evaluate the print and see how well it printed. And depending on that, we remodel the parameters, and it's an iterative process where we continuously doing this until we get the best result. So these are some of the brailles we have printed. The first one, the one on the left, is our first braille script, and we got this from a site called instructable.com, which showed us the default settings that you need to have to achieve a readable script. The second one is what we achieved to do, our general overview, which is the text that we are going to print. It's going to present you the information of the plant, and then it's going to guide you to the QR code that will show you the audio translation of the plant, and it will give you more information then. Finally, after developing these, this is the new process that we are going to do. So we're shifting from a PLA filament to PETG filament because it's more chemically resistant, and since these braille scripts will be put outside in nature, they're also weather resistant, so it will be better for that. We're also planning to fine-tune the printer settings to get finer and finer prints. As we said, it's an iterative process. And finally, we're also deciding to add in post-processing, which is using a fine grit sandpaper to sort of take out the over-extruded parts and the plastic parts that are unnecessary. And this is the last part. We haven't done it yet, but we're planning to send these scripts to our code designer in the Montana School of Deaf and Blind and ask them for evaluation, sort of conduct a survey to get more feedback on how to improve the project, the braille scripts.
Okay, so sorry.
Talking about the process of the tactile images, for the process of printing them, we initially trace the image of the specific plant through Inkscape. We will trace and focus mostly on the important parts of the plant, so the parts that like really make it unique and recognizable for the person that will be touching it. And then after finishing the tracing, we would import the SVG to Fusion 360, where we would extrude the design, and each part of the plant had a like own height, varying from 1 mm to 4 mm. The variation of the heights would create a contrast, making us feel like the details of the plant. And then lastly, we would export the final designs to Ultimate CRE and send it to the 3D printer. The estimated time of printing will be around 1 hour to 3 hours, depending on the size and complexity. We also faced some challenges. As we printed some samples, we would check if the final product would really emphasized what would be the focus of the plant. If it didn't, we would go back to the beginning and then change what was necessary. As you can see, it was needed to print the purple prayer clover image 3 times until we achieved the desired result. As you can see, there was like some changes in the petals and also on the whole plant itself. After all finished, we will send them to the school for testing and then get their feedback and make the needed adjustments.
Yeah. So overall, this process has definitely been very complex. We faced a lot of trial and error. And so here, Julie and I will tell you a bit about some of the lessons we've learned during this process and kind of what insights we have gained as high school students working on an assistive technology product. So what have we learned? I'd say our 3 biggest takeaways come from 3 main ideas: perspective, trial and error, and communication. With regard to perspective, the inclusion of a co-designer in this competition has definitely gave our design process a unique twist in that it moves us beyond the scope of simply creating something to create something, but rather moves us into an area where we have to actually deeply understand the project from the point of view of the person we are working to help. And so in doing so, this really causes us to truly think about how we can best maximize our project, and as well as kind of offering a unique approach to the technological product development of this project. I mean, a big example of this has been having to figure out how to create a product that feels like a plant rather than just looking like a plant, which is very different from how most of us in our group think of a product. So it's definitely been, yeah. And then with regards to trial and error, the engineering design process definitely comes with, as Julia said, a lot of challenges. As stated, we have definitely faced our fair share of tribulations, from, simply crashing the Fusion program to having trouble extruding certain parts. And in the face of these, we've definitely had to start over many, many times. But as a team, we've gained the confidence to kind of take a step back, look at the problem, reevaluate, and come up with a solution. And I think that process in itself has been a very important takeaway from us from this project. And then lastly, with regards to communication, communication with the co-designer in this process has proven to be very imperative. Getting kind of feedback and making adjustments, I think, really helps us best fit their needs, as well as sharing ideas with others within our group also gives us a different insight into how we can best optimize our designs. And overall, by simply talking, we're able to work better as a team so that we can best benefit one another.
And then now going forward, overall in the next coming weeks, we plan to send in some of our prototypes, plans, representations to the co-designer and get some recommendations. Work with various Fusion tools to see what creates the optimal Braille screen. And then meet more of the co-designer via Zoom to get a better understanding of our project and how we can make improvements. And finally, overall, hopefully come up with some usable versions of our prototypes.
Thank you for listening.
Thank you.